Were no introduction, but this session is a special lecture. Every year, August 7th is Professor M.S. Swaminathan's birthday, and we used to commemorate with an international conference. And this year's conference is Hunger-Free World, Professor Swaminathan's Vision for an Evergreen Revolution. So yesterday we had a series of sessions, and today we start the whole day with your special lecture. And chair is Dr. T. Ramasami. He is a distinguished scientist, technologist, scientist, and former secretary to the Government of India in the Department of Science and Technology. He is our trustee also. And he has authored over 250 scientific papers, holds more than 50 patents, and developed 12 processes know-hows. His leadership at CSIR, Central Leather Research Institute, transformed India into a global leader in the leather research, and there are many laurels for him. He is a pioneer. His pioneering programs like Inspire, Purse, etc., really also revolutionized India's scientific landscape and so on. Recipient of the Santvi Swarup Bhatnagar Prize and Padma Bhushan, Dr. Ramasami continued to impact academia and as an honorary professor, and and there are several awards in his CV. And with this brief intro, I am also have the pleasure in introducing Dr. Somanath. He is a distinguished scientist and secretary to the Department of Space, India, renowned for his nearly 38-year career in space technology. As chairman of ISRO, he had successful missions including Chandrayaan-3 and initiated the Gaganyaan program. His tenure at the Vikram Sarabhai Space Center saw advancements like LVM-3 M1 Chandrayaan-2 mission. He pioneered the development of small satellite launch vehicle SSLV and reusable launch vehicle, etc. Dr. Somanath holds multiple honorary doctorates and is a fellow of prestigious academies. Recognitions including National Aeronautics Prize and Space Gold Medal. His vision focuses on Space Vision 2047 missions, including lunar exploration and Bharatiya Antariksha Station, etc. Sir, this is with brief introduction. I hand over the chair to Dr. Ramasami.
Very, very good morning. Hariharan said he stands over the chair. I can't handle the chair. I thank the organizers for this opportunity to be here today to join this seminar, international conference, with a role to play in this special lecture series. It gives me two advantages. One is to pay my respects to Professor Swaminathan as a kind of an opportunity. As was said, somebody was saying yesterday, he has known Swaminathan for so many years. I am going to say this: Dr. Swaminathan knew me for 38 years. Therefore, it's the other way around. And I would say, for people like us, he was a role model and somebody, a pole star, on whom we follow. Gandhi talked about leaders. Leaders are those selected by the followers, and their followers don't select them. They essentially we follow them, and therefore followers select the leader. That is Gandhi said. I think Swaminathan is one such individual. And it is important on this occasion, in this special session, to quote Professor Swaminathan. He used to talk about, unless you nourish the root, you can't bear fruit. It is nourishing the root and bearing fruit, and I really see this new logo have lots of roots on this. It turns out that I have heard Dr. Somnath's name before I saw him. It so happens that when I was in the government, he used to be told to me, his name is, he is the future chairman of this space organization. And I would say Dr. Vikram Sarabhai and Satish Dhawan nourish the root and he is the fruit. for this entire space organizations. Let me congratulate ISRO and Dr. Somanath on this occasion, apart from the fact we welcome. Today this Vigyan Puraskar has been announced, says a space team has been given the recognition. And it's a first recognition of this kind of systems. Congratulations on behalf of this process. I mean, to a learned audience of this kind, to introducing Somnath is like carrying coal to Newcastle. I lived in Newcastle, I won't carry coal. His contributions, the space contributions particularly, have impacted the country in more than several spheres and tiers of life. It is befitting that when we talk about the vision of Professor Swaminathan, the Evergreen Revolution, he talked about how new technologies coming from the space can actually impact people working at the grassroots and farmers community. I congratulate the foundation for the recognition that we did yesterday on the space-related program launch. I think here he is going to speak to us about how the new emerging and cutting-edge technologies could play a role in empowering farmers. I'm not about technology, empowering farmers in the livelihood. It's my pleasure to be a part of this session. I will not introduce him, I'll present him to you to take this lecture forward. We wait for you specially. Thank you. Last 5 minutes, questions will be there?
Oh, yes. Okay. So I can use the PPT, right?
Yeah.
So we can connect this now.
Can you connect it from there? So it will be shut off.
Huh?
We'll connect it
No,
from there.
wait a minute. I'll copy here and I'll take a copy also.
No, you can use
Just Zoom call.
Okay, I think we'll start by the time the presentation is copied. So good morning, all of you. So thank you so much for this opportunity to be there with you on the occasion of this national conference, International Conference on Hunger-Free World, Professor Swaminathan's vision for Evergreen Revolution. So on this second day, to start with, on a topic of space, technology, applications, and its relevance for governance and sustainability. That's what I would like to talk about. I think all of you know, I think I don't have to speak to a very informed audience on the nature of our country, India, its population, its natural resources, and the challenges that we face in terms of the governance and sustainability, to keep our country hunger-free, to provide resources to them, to plan and monitor. I think all of these are very important topics, and how to help governance of all of this through the space technology has been all the time a topic that we have been discussing in ISRO. And whatever we do, one of the focus continue to be this, in creating those type of sensors, space platforms, and support this activity. And we have been doing it for the last 40 years or so, ever since that we started launching satellites and imaging through various developments that happen. So I will just quickly go through that, as well as also look at what are the priorities areas that we are working, and what are the problems that we face in terms of application of this space technology for those goals that we have set for ourselves. Though that we have set many goals for ourselves, I won't claim that all of these are achieved. or we are on path of achieving all of them. Unless we bring more stakeholders and support system into it, it won't be usable. So I'm not going to go into the statistics of all of this. So various problems that we face today are primarily related to agriculture, the productivity, planning, land resources and its utilization, weather and climate changes and how we can support modeling, prediction, etc. And finally related to sustainability. So we believe that the space technology has an ability to bring a very synoptic view of these issues to the community, to the decision makers, the scientists, especially in terms of the natural resources availability, its planning, accounting, management. Also to support the governance as well as the national security. And of course in terms of the economy, where in terms of improving the quality of life and livelihood. These through various interactions, interventions, especially in terms of agriculture. I will go into the specific details, so I won't spend time here. Land degradation, bioresources, conservation issues, disaster warning, mitigation. In the recent times, the disasters are becoming all the more important, and what type of support that we are able to do. And climate adaptation and really those measurements through the space and other terrestrial measurements. And similarly, including all those infrastructure which are needed. It's not just imaging that will help you ultimately, to the sensors that will help you. You need to have a communication connectivity across various places, and how those technology can really help you to do this. All of you are aware of the SDGs, and of those 17 SDGs that we have set for this region. We know that today many of them are become very important topic when we plan our space systems and include in our measurements, include in our sensors and monitoring and providing on a continuous basis updates of this through our many portals and information systems that we provide. Because this is very important for me to come and speak here, because unless I do this type of activity, I believe that the awareness about itself is very low in the community. Though we do put a lot of information in our sites in related to this, I am very well aware of the type of utility is still very limited, primarily because of this issue of awareness. Because we deal with ministries, governments, departments, stakeholders of various states, but still there is so much can be done through the people, NGOs, industries, startups, companies, etc. So which is something very important. So we have a very clear plan of action to deal with the most of these application programs dealing with these SDGs. In terms of the ability of technology, I think we talk about ultimately in the utilization of this data, but we need to develop technologies to enable us to measure it. I think when you are measuring far away in space, something like 400 to 500 kilometers up in the sky, unless you have the right type of sensors, you won't be able to make any physical sense of what those measurements are. It goes with the technology associated with the sensors. Over the years, we have been developing a series of technologies. I am not going into those names that are written here. We call them push broom, we call them 3-tier imaging, step and stare, the stereo, radar, optical, hyperspectral, altimeters, things like that we continue to develop, because with the times, many measurements capabilities are improving, sensors are improving, and we are able to get higher resolution. We started with kilometers of resolution. Now we are talking about centimeters of resolution. We also talk about spectral depth. Earlier we used to look at from the optical. Now we look beyond the optical. So you see from infrared to ultraviolet, X-rays, radars, all those bands that you are able to see, and also much more narrow bands, so you can distinguish between features, understand them. So this continuously helped us to create data of very high quality, where you can make a correlation between those observations and physical measurements, and how to make sense out of it. For example, if you want to measure water vapor along the height of atmosphere, earlier it was not easy. Now we know how to get even those type of information over the height, not just the surface features in the atmosphere also. So if you have to get those type of information, we need that type of measurements. Today new technologies emerging like GNSS based. We are going to launch this coming August 15th, the satellite which will use signals from another satellite to measure certain geophysical parameters once it travels through the atmosphere. And the recent satellite we launched, the INSAT series of satellite, the climate and weather satellite, one of the best in the lot. Every 15 minutes we get an image of the entire country, and gives us the cloud cover, the wind vectors, the humidity, water content in the atmosphere. So much of information comes ultimately we have to make use of all of this to make good models and predictions. We have a large number of satellites even now operating. We have the one which look at or resource mapping for the land. So we call them resource sat. We have cartosats which looks at high resolution imaging, mostly in the optical band. Then we have all weather day and night imaging radar satellites. Then we have a specific satellite which look at the wind vector, the sea salinity, the sea surface characteristics. Then we have ocean satellite, which is a thematic satellite looking at ocean, the chlorophyll content, the ocean waves, the fish prediction, fish school measuring. Then the climate and weather satellite, which looks at the cyclogenesis as well as the climate and weather related measurements. So all these class of satellites are currently operating and giving data. But there are limitations of all of these satellites because they don't look at on a continuous basis. Our revisit capabilities are limited. They don't look at every half an hour you don't have an image. Sometimes it goes into days and weeks because the numbers are less. So we have to look at how to increase this throughput because look at the Wayanad when it happened. We were not having exactly at that time. There was no image. There was a huge cloud cover. We were not able to have the radar image at that time. So these deficiencies are still there. How to overcome these deficiencies is another topic of discussion. Right now, the government is asking us that you should build these satellites not just as a public delivery system, but it should be connected to the user. This is very important policy direction. So we talk to ministries, departments to create that type of demand within them so that ultimately the satellites be used and funded, monitored. So we have a new mechanism by which future satellites are being built. And commitment from the departments and ministries and users are already available a priori before we build it so that the entire chain of utilization is put in place. It was not the case earlier. So with that type of aggregation, we have another 7 satellites in the making now, which will be launched in a few years from now. They again look at augmenting these capabilities in resolution, spectral capability, temporal resolution, all of them. So we have and this gives us a very huge visibility of data for all of us to make use of in the coming days. Now looking at the utilization of this satellite data, I think all of you know that essentially these are meant for governance. We call it ultimately governance. So we look at water security. So today because of satellite data, we have one of the best ever water management database today, which the ministry is using it for looking at the land, surface water, the underground water. The entire quantification of this is available in India today, even to dig wells or even to predict how the changes are happening. The salinity in water that is increasing. We also look at the water level dropping at an alarming rate, which is almost 3 times that has been in the past. We look at the seashore, coastal erosion issues, which I will tell you. Disaster and related information which again comes out of it. We look at energy security, infrastructure, the roads and bridges and ports development that we continue to support. Food security is again another important topic which I will again very important topic that need to be addressed. So all of this area we contribute, and we also have along with this observational capability we had another two important capability, that is a communication capability. You give point-to-point communication, broadcasting services, internet services, which again supplements this. And the last one is the PNT services, the positioning, navigation, and timing services, as you call GPS. Though GPS is a US one, we have the one called the NAVIC, which is still under building process, and we are in the process of building it to provide a very high resolution GPS-like services for our country. Now, looking at the food security, we have a very important topic, and we work with the department of concerned departments which deal with this. We have a center called Mahalanobis Crop Forecasting Center, which looks at crop yield estimates based on the national data. Today we have 8 of the crops which are under operationalized for pre and post harvest predictions. Also in the horticulture area, also there are 7 crops which are now under full prediction capability, where we can look at the site suitability, the advisory for planting, etc. can also be given. So this is now operationalized based on a large number of data generation from both from space as well as from terrestrial data. Again, another important support is in terms of wasteland monitoring and degradation of lands and how that can be used for reclaiming and then improve the productivity. Similarly, we have a specific topic on Eastern India area where we look at Kharif crops and look at how we can post-crop look at the conditions of the land, and then advisories can be given for one more yield in case of the water content in the surface is good enough for one more harvest. So all this allow the fallows to do short duration pulse crops, etc., to improve the productivity. Similarly, on the this is specifically that what I mentioned about the fallows, where they look at the short duration pulses after the primary crop is over, and then look at how farmers can have a second provision for additional crop yielding. So this certain estimate has been done on the outcome of it, which is really good in numbers of net profit earned, etc. Those numbers can be discussed or questioned, but then these are type of numbers that people estimate to show you that this data can be well utilized. Another important topic is about the Oceans Act, which is, as I mentioned earlier, we provide advisories on fishing area, and this comes out of many measurements. It looks at the ocean color, which talks about the chlorophyll content. Then we have the ocean wave vectors, the surface height, the salinity, etc. And based on this data, certain predictions are done on the model, and this model tells you where the fish schools are possible. You can go there and catch fish better than that randomly going around and doing it. It actually helps. But then here again, the problems are in terms of dissemination of this information, appropriately reaching the fishermen, making them to make use of it on a sustainable basis, so that it is actually put to use. Only the utility is still very low, primarily because they are not aware of the type of people who are connected with them are not good enough. So in fact, I have been telling people that this information is so much available, and how to commercially exploit this data so that really the benefits are coming. So this is something that I am looking at even companies and startups to provide us a service at cost, because this will, if you do it at a cost, people will really see its value. Now it is all free, because free is creating problem for people. They don't really trust it. They don't make use of it. So these are the type of issues that we need to overcome to make it reachable. Again, delivery through the social media to the apps, etc., is also important, because earlier we put it in some websites and some location. Who will go to the website and pick this data and use it? So ultimately, the last end delivery becomes a major topic. Though we have all these technologies, ultimately it must be reaching people. These are major challenges that we are looking at in the present. Okay, one example I will tell you that right now we are working on 1 lakh mobile handheld service terminals to fishermen at Tamil Nadu coast. So this is another work. Another 10,000 are already ready, which is going to be distributed. These handheld devices are having so much of features that can do bidirectional communication when they are deep in the sea. They can do a fish trade on website based trading services. They can collect climate and weather updates on sea states at cyclone genesis, etc. Also look at the boundary GPS locations, where how much they are crossing. So much information can be given if they install this in the boat and use a typical standard mobile with an app. So this is one activity that we are taking, and realize at least 1 lakh terminals to distribute it all across the country. Now this is coming through the fisheries department. We are realizing through private companies and supplying. Yet another interesting topic of work is in terms of energy. I think the energy means solar energy, wind energy, etc. So this is being mapped throughout using satellite data. We have now there is a solar calculator you can download and use it in whichever location in this country you want to put up a solar plant. What's the type of yield, annual yield, the estimates, etc., based on the insolence and related geographical data, the building blocks, the terrain blocks, etc., will be estimated, and you will be given an estimate based on the data itself. So this is an important tool available. Similarly, you can also look at where to establish wind turbines, which is the best location. It's also available through our website. I'll tell you where to look for it. Even in sea, we have recently done studies of best place to locate wind plants, and some of them are getting ready in the coast of Tamil Nadu as well as in Gujarat based on this database. So this is another interesting topic that comes out of the space-based measurements. On the environment and ecology, I think this desertification, land use degradation mapping has been an activity we have been doing from the very beginning, because it is very easily possible with the optical data sets. Similarly, the biodiversity characterization at the large scale level, and much of the data is continuously updated. It is a periodic update based on the satellites that are coming. These are campaigns that we run to map the entire country, and then provide this database as a resource for all the users, planners, etc. And all of you know the biodiversity of our country is really, really one of the best. We one of the 15 most biodiversity prone nations of the world, and it is important that we need to catalog them, create database about them. So vulnerability of these start to be assessed and give warning. Of course, we know we are not the people to act on the ground, but at least if you are able to provide this information, the concerned departments, ministries, users will be able to be highlighted about these issues and take actions. So these are the hope and information that we are able to provide. We have created enough of the vegetation mapping, species identification based on the gross level information that are available from space. Similarly, some of the important activity we have recently done is to enable village panchayats do their own planning. So some of the training that we are given to thousands of panchayats, we moved around and then gave to the sarpanchs, etc. Suppose you want to look at your panchayat alone, how to do a planning. For example, if you want to build a new school or build a new hospital, what's the right place to build? And we will be able to give an advisory, a tool on how to plan it, look at the roads, infrastructure, the location, the terrain, the distances involved, the communities which are accessed around it. So a lot of analysis can be done, and they can locate multiple options, what will be the best one for a village panchayat to choose. I think such tools are also provided in our websites for enabling. For that, we have given trained panchayat sarpanchs for doing this. So this is yet another aspect of it, which will also provide other holistic information about the crops, agriculture, nature, the utilization of the land, and into it, so much of databases have come over the years, how it has changed over the years. High resolution data will be continuously added to create this, and this is done in our portal called Bhuvan. Possibly you all will be advised to at least look into some of these portals. Some of these who are working in this domain, of course, they know, but otherwise everybody can actually look at it and then keep an eye on what is actually there in the databases that we have created. Climate change and its impact is another area. There is a National Information System for Climate and Environmental Studies, NICES, which is piloted at Hyderabad in our National Remote Sensing Center. This is not a center-specific activity, it's a national activity, multi-institutional. Not only ISRO is partner, and many other institutions are also partners in this. Here we continue to measure at least 67 geophysical data and also 13 essential climate variables data that comes out of the measurements. And this is not done from space alone, it is also done through our terrestrial measurement system that have been installed, where the data collection is through the satellite platforms. And this are actually shared between various researchers that are working in this area, and many algorithms, data retrieval methods, etc. are also developed along with this. So it is another very important topic of research. Though we do not have much of climate research scientists within the organization, we are more focused on measurements and providing data. The ultimate use of this data in terms of climate modeling all comes out of other ministries who are working in this sector. So we tie up with them and provide all this information for weather and climate modeling studies. Today we are discussing on the coastal issues. I thought that we should also talk about some of the important measurements that we have been doing over the past. So very important observation has been on entire length of coast of India, and over the last many years we have been mapping it regularly on the changes that are happening on 10-year basis. And if you look at this, it has been very interesting aspect has been seen that almost 15% of the cost has already eroded substantially, but also additional 14% of land has been added some places. So this is very interesting, where it is getting removed, where it is getting added, and rest of the areas it remains unchanged over the last 20-30 years. So this is shoreline shifts have been well looked at, and what are the reasons for such this are subject to research. Whether it is the construction that is taking place or natural processes that are taking place is something that need to be addressed. But this data is already available, and we indicated this data for all researchers to make use of. One example is that our area where we have around 55 kilometer shoreline at our launch complex called Satish Dhawan Space Center SDSC, and this almost this 53 kilometer long coastline significantly eroded We have seen almost 250 meters of that has been eroded where our launch pad is sitting there. The sea is so close to it. So we looked at how to protect it, and we are now looking at how to protect these type of erosions. In fact, some of the roads that were there in the coastal all vanished. Now it's not there at all. So much is erosion because of various reasons which I don't want to go through. But then this is something that we need to look at on a continuous basis and look at action. So space can really help you to. Over the years, we can correctly map this data and then find out what type of changes are actually happening and what are the reasons triggering it. But this research should be supported by in situ measurements of the current and other related parameters that should be done along with this type of data. We also work on e-governance. I think this is another important topic with the type of data that we supply for e-governance activity is very, very important. We have many of the central government programs where we look at the MNGREA program, which is very important. Geospatial tagging of infrastructures that are created through this process is very important topic, like roads or village panchayat or water tanks or whatever is created, you can actually geotag and put it in the website so that you don't actually duplicate them and misuse those funds. So these geospatial data sets have been very useful. Similarly, on building the rural roads and housing through various programs of government, how to monitor the infrastructure progress through geospatial data. Watershed development programs under different projects is again another topic. So this PM Gati Shakti program, everybody speak about because it is primarily driven by the geospatial data sets related to the roads, airports, building, waterways, logistics, etc. And all these are built into it. And the utilization of this spatial data for this primarily for Gati Shakti program has been very phenomenally successful, and many of the planning that is done for power lines laying, gas line laying, etc. has been well utilized in the recent times. Disaster risk reduction. This is major area. Wherever I go, people ask me why you are not able to forewarn many of these incidents. But this is a topic that we must address, all of us, because we, most of the time in disasters, it's a post-disaster support only is being provided through space-based data, especially in terms of early warning. Cyclone has been a success story. I think all of you know that currently the type of data comes out of satellite is very well reliable now about the genesis, its track prediction, the landfall and the type of damage area, etc. are well calculated and warned. So administrations near those states are taking actions now. Because of that, your fatality rates, etc. can be substantially reduced. I think all of you know that today you don't hear about much of those damages. It's a real success story because of the INSAT series of satellites. Today we know there are 3 INSAT satellites up there. One is almost getting its life ending. So the brand new is also there. So we are continuing to provide the next generation of satellites to do that. But if you look at the land and other related issues like what happened in Wayanad, how to really predict it a priori, like how to look at the rainfall when you have a severe rainfall, landslides initiation, or soil water content reaching saturation levels leading to slopes, how to map those slopes which are dangerously placed, and how to put sensors in this location and connect it through satellites. These are topics that we should take seriously. At least those vulnerable areas we need to instrument it so that we will be able to forewarn it at least few hours before such incidents. I think it is very much possible. Similarly, other issues like the flood alerts, flood inundation maps. I think we have time up. Okay, so forest fires is another area that we have been working. Forest Survey of India is very much happy with us. I'm concluding, but I'm not. Okay, now coming to the information dissemination, we have different portals. So this is something which I would like to tell you, that we have PUN, which is many layers of information are there. Some are there for public, some are not there for public. So those who want to make use of it can register and use it. We have a Bhunidhi portal, which is a dissemination portal for data. MOSDAC, which gives you the weather, climate related data. And all this data is available in our different websites, and if you become a registered users, we can actually provide you up to 5-meter resolution and coarser resolution data free. Now, based on the new geospatial data policy, is actually free, and higher resolution data can also be made available substantially low cost. So this is another important change that happened recent times to make this sector grow. Also building new set of satellites with new sensors. I think I already mentioned very high resolution like for 30 centimeter and below are coming up. also radar satellite, meteorological satellites, ocean series in the new types, and also working with NASA on the synthetic aperture radar, L and S band, which is going to be one of the best satellite. Every 15 days we'll have a full map of the entire world with high resolution, which gives you very high information in L and S band radars. Thermal imager, which is going to be very important for looking at the land use and land cover studies. We look at various long-term proposition on how to build this, improve this capability. This is one of the important area. The one which we are going to launch in the August 15th contains two important payloads called GNSS reflectometry, and how that can be used for climate and weather, looking at land utilization, land salinity, water content on the sand, soil, atmospheric humidity, etc. So these are measurable using very passive sensors. So and again, we also look at how to process the data and make it available at fast track, because today it takes days to process the data, maybe some cases hours, but how to make it real time available to users is another important topic. So let me conclude my talks today saying that the work that we have been doing in the past on space-based data monitoring, support for sustainability and governance has really made an impact, with almost 18 satellites currently working in space for providing this data, supplemented by our communication satellites, which again another 20, GNSS satellites another 8. I think this is a really phenomenal system, almost 50 satellites. But for a country like India, it's just not enough. We see that it must be tripled or quadrupled in the coming days to support this area. And finally, though we have so much of data, its utilization in downline application is still a major challenge. Here is where the new players to come in, either in the form of NGOs or in the form of business opportunities. How to make use of it is something that we need to work on. So let me all invite you for the National Space Day celebration that is happening across the country to celebrate the Chandrayaan-3 landing that happened on August 23rd. So this is the first annual day of that, celebrating the Indian capability to send a craft to the moon and land on the southern side of moon is considered as one of our very important technological challenges which enable us to dream bigger in this sector. So welcome for that, and thank you so much for this opportunity. Yeah.
Could you have 2 questions maximum? Any questions? Yeah.
Yes, thank you so much, Dr. Somanath, for that really excellent overview, and what an inspiring set of programs that ISRO has been able to develop over the years. Most of them can have societal applications, as you rightly pointed out. And I think Professor Swaminathan and leaders in the space program earlier were all convinced that it had to be taken, especially for farmers, food security, etc. So I was wondering whether we need to think about a program of citizen science, because ISRO is generating so much of data from satellites, and as you rightly pointed out, there are a lot of young people in every community today who are very tech savvy. And I think with a little bit of training, especially for this things like early disaster warning, mapping for every community their own local resources and how to use them optimally, and with more and more climate disasters expected, I think we have to build that capacity on the ground, because it cannot be a centralized one. It will have to be very much driven by and involving local communities. So I think we need a big program like that, and I wonder if you had any thoughts. Maybe we can take the second question and then you could...
Excellent talk, Dr. Somnath. I am Prasanna from International Maize and Wheat Improvement Center, CIMIT. A question I have is, most often we rely upon European satellites for our satellite imagery analysis in our research. How can we utilize the Indian satellite imagery data in agricultural research applications, including crop phenotyping, analysis of pests and disease monitoring, and risk prediction?
Yeah, these both are connected. This again that talks about the extent of utilization of our satellite data. There has been hindrances in reaching to the data. I can really understand this issue. whatever data we generate, we stay in our data centers. The access to this data for the users has been limited because of various policies. I think this policy has been one of the issues. In Sentinel data, for example, from the Europe has been freely available, much more faster. They have made it a mechanism by which this data drives the economy. They realized originally when this data was created by the government with the governmental investment, and how this data should be disseminated. There were questions on how to commercialize it, because finally you need to find a returns of investment. Europe started selling it data at cost. Then the utility of the data came down drastically. And they made a policy change in which the entire data is made free and citizen-centric. Everybody will get the data free. And they realized that after that, the utilization of the data increased and corresponding economic activity on the data-based activity came up in Europe. And that's why you are able to get those European data much faster than the Indian data. And this was a policy issue within India. We were not allowed to distribute it freely, but this policy change has now occurred. Up to 30 centimeter, we are allowed to give free. But then free means where to go and ask free. That also is not available. So we have to create a database where you can actually go and get it whenever you want. You mark a location, you get a processed data or a value-added data much faster. So this is next action we are going to take. The entire 30 years of data, we are moving to another database today. We are handing over to a private company to operate it and give it to you instead of government operating it, so that you can get it at very nominal cost. Only the data transfer processing cost only it will come, not the data value. So this is one step that we are going to take. And second is we have to support, as Madam said, to make it more citizen-centric. One of them is to support universities, students, etc. to work on this data, encourage startups, etc. who are working in this data. We are conducting now hackathons on proven-based platforms for enabling students to understand how this data is available, how to make use of this data, make some utility out of it. So one hackathon is currently running in Hyderabad with hundreds of students and university students participating in it today. We'll be announcing the winners. We have been doing it at regular intervals. So I will suggest you to go to these websites and find out how to bring in more communities to be made aware of it. Thank you.
Thank you. Since we have asked, there is a question relating to this. I'll fill up a little bit more information, because there is a National Data Sharing Access Policy of 2012. It talked about, because National Data Sharing Access Policy 2012 is ahead of the policies taken in the Western world in terms of time scale. It had 3 types. Free use, any government-owned data must be accessible to civil society. And that can be for free use. That can be for registered use, regulated use. And there are pricing patterns. There are certain things you can know a pricing pattern. 2012 policy, you can go and look at it. As a result of that, even at that initial phase, some of the young people in the colleges were able to develop apps to do a price discovery for agricultural products on real time. But it so happens we are very good in initiating things, very poor in translating things. So what is needed is essentially a national effort to convert this entire data assets that our space agencies have produced and the ground truthing that you can provide, because the ground truthing is crucial, because remote sensing gives you. So there is a civil society organizations. I think the next generation of Indians are aspirational. I'm sure they will take it. I think today, I would say the space gives you a third dimension. People of our generation were surfaces all the time. The third generation added, I think your technology is adding a new aspirational process for this country. Thank you very much for what you have done to us. Thank you.
Thank you, sir. I request Ramasami to hand over this millet basket.
This is on behalf of the trust.
And it's my pleasure.
Thank you. In the left hand, give it the right hand.